Alright, here's an update on my software-defined radio project. As you can hear, it's working much better, and as you can see from the waterfall here, I've eliminated the mirror imaging. So there's some guys here on single sideband. This is my carrier leaking in. And this is the entire bandwidth of my sound card. Let me mute this and I'll come back to it in a second. Alright, here's the new board. So, the new board works much better than the one that I messed up by letting light leak into the room as I was doing the photo process. In this one, I've changed the circuit quite a bit. I threw out a bunch of stuff just to reduce the chances that all additional circuit was causing the problem. So what I have here is a linear power supply. It's generating some voltages I need. The local oscillator, which is just a CAN oscillator unit that I can swap out. A 74 HC74, which is hooked up in a counting arrangement to make my in-phase and 90 degrees out-of-phase signals, which drive an HC4066 analog switch. Now this is a little bit different than the other circuit because the other one used an analog mux, and I only had one of those, and you know, I was a little suspect that it could be damaged, so I changed the circuit around to use one of these instead, which I have a whole bucket of those, so that's good. So this is the direct conversion detector here, and tie-low, the commutating thing, you know, I talked about in the other video. And this is the op-amp that's increasing the gain and coupling that to a PC sound card through this cable. Then this is my RF input coming from my dipole antenna that I strung up across the backyard and driveway. And that runs down to a biasing circuit which puts it mid-rail between ground and VCC so the op-amp stays within its operating range. So that's pretty much it. I have some interesting artifacts happening, mainly because I don't have the front-end filters on it yet, and it's not shielded, and my audio cables and power aren't properly filtered yet. So let me show you what's going on. So we can see what looks like a couple mirror images there. If I take the entire unit and pick it up, look at that, they go away. So what we're seeing is direct coupling from all of this RF coming off the laptops. So as I wave it around at different electronics, we can see different harmonics popping up and showing up on the display. I've got this little unit here. This is a grid dip meter. It's used for checking tuned circuits, but it's pretty much an oscillator, and I won't go into how to actually use it, but it has a dial that I can adjust a frequency, and it's broadcasting a frequency out of this little coil unit here that can be plugged in. So I've got it tuned close to the frequencies of this crystal right here. So let me switch that out and let's take a look at that, and then we'll play with this a little bit. So let me unmute the audio just for fun. So we're dividing this 40 megahertz crystal by 4, and that brings us to 10 megahertz. So if I come over here towards the center where the carrier frequency is, there's our atomic clock, WWV, WWB, I always forget the name of which one. Let's see some other stuff that's going on in here. Some kind of data communication happening in there. So we'll go down here to this guy. Let me tune this one in. So as I move this dial, you can see these signals showing up right here. There's a mirror here because I'm so close that I'm just overdriving everything. But if I move this away, alright, so I should be able to play around and see where I'm receiving my unwanted signal. So I'm going to put it next to the sound cable here that is really coupling into the circuit very strongly. Alright, so pull that away, and I'll move it over by the power supply. Let's see how my bench supply is doing as far as... That's coupling pretty strong too. Now if I put it by the coax, let's see, and I'm right up against the coax, so there's not a lot of unwanted signal coming from the coax, even though it's just going out to a dipole and it's not earth grounded. So I think what I really need to do is get this into a metal box, get my bandpass filters on the front, get my FPGA local oscillator going, and get some RF chokes and filtering on the power and audio to keep the nasty harmonics from the laptop from getting into my delicious software-defined radio, soon to be FPGA-defined radio. This is going to be part of the next Element 14 video on communication. So, hope you enjoyed another ramble video from me. Thanks for watching.